Hello my dear students, I am your teacher Arpita Sharma. Welcome to AriserTalent. Students, we were discussing chapter triangles, and this particular chapter triangles we were discussing theorem. Theorem to related what? Theorem to related area, right students? So, we were discussing a theorem based on another theorem, and that was theorem 2, which was related to theorem 1. Okay. If the areas of two similar triangles are equal, then the triangles are congruent. That is, equal and similar triangles are congruent. Okay. So, it's saying that areas of two similar triangles are equal, then the triangles are congruent, that equal and similar triangles are congruent. Right? Okay. So, let us see. To see all this matter, we have to draw two similar triangles. Mark it A, B, C, D, E and F, like you always used to do with me. Okay. Now, we have drawn these two triangles. Now, it's saying that area of these triangles are similar. Okay. So, given is what? Area ABC is equals to area DEF, right students? Okay. Now students, I have told you that we will use the previous result in this theorem. So, in previous result, what we have discovered that area ABC, area triangle ABC, okay, I haven't written triangle here, so you should tell me now, okay, area triangle, right students? Again here area triangle, okay, area of triangle DEF is equals to what, my dear students? AB square by D square equals to BC square by EF square equals to AC square by DF square, right student? We have acknowledged this, right? Now, next is what? What is next? Okay, let's see how it's gonna work. We have to prove that these are what? Congruent triangle. Now, I can say that these two triangles are congruent if I proved that the sides, the three sides of one triangle are equals to what? The three sides of another triangle. Then by side similarity, I can say proudly that this triangle is congruent to what? This triangle. Okay students. So, let us do this. What we are having, area ABC by area D, E and F. Again the same mistake, I won't write the triangle sign. Okay, area triangle ABC will be divided by area triangle DEF is equals to what? These two triangle area are similar. Now, if area this equals to area this, then this will be dividing by the same thing is equals to what? 1. So, I can simply write it 1 here. So, what? 1 equals to all these proportion AB square by DE square, and so BC square, and so AC square divided by EF square, and so FD square. Okay. So, That implies that AB square equals to DE square. By this we can say, and BC square equals to EF square, and AC square equals to FD square. Now it's easy, student, that square will ultimately cut. Okay. So what will be remaining? That AB equals to DE. Here we will be having BC equals to EF, and here we will be having AC will be equals to FD. Now my dear student, we have seen that AB is here. Let me pick 3 colors chalk, and I am lacking one. Okay. So it's saying what? AB, students, AB is equals to what? DE. These two are equal. Okay. Now BC is this, equals to what? EF, right? And that AC is equals to what? This FD or DF. Now you can see these 3 sides are equal to these 3 sides. So by side congruency, we can say that these 2 triangles are what? Congruent. Okay. So by side congruency, triangle ABC is congruent to triangle DEF. And my dear students, isn't it the same? We have to prove that if the areas of 2 similar triangles are equal, then the triangles are congruent. That is, equal and similar triangles are congruent. So we are having to learn that if you have given 2 equal and similar triangles, then these 2 angles, or sorry, these 2 triangles are what? Congruent, students. Okay. So note it. I am going to rub this. So much of theorems now, students. So we will be doing some what? Some questions based on these theorems we have studied, right? So let's have a look that, but what you have to do, that just don't prove the theorem and forget it. Don't do this. Remember the theorems, because you have to, I have told you, you have to take care of this, that these theorems will be given in some form in your questions. You have to find out the thing and apply the particular theorem in that question and do the numericals, and you'll put the values and get the answer. But for that you have to remember the theorems. Okay. So remembering theorem is very important. Now the question is, in 2 similar triangle ABC and PQR, okay, if their corresponding altitudes AD and PS are in the ratio 4/9, find the ratios of the areas of triangle ABC and triangle PQR. So let's see what it is saying. We are having 2 similar triangles ABC and PQR. For sure we are known to this. So just draw 2 triangles which are similar and name them what? ABC and PQR, not DEF. Now if you have given with the names, you have to write it as given if their corresponding altitudes. Now let me draw the altitude AD here and the altitude PS here. So these are altitudes to triangle ABC and PQR as we have asked. So now see again, we are having this triangle ABC and this triangle PQR. These both triangles are similar to each other, and we are having this altitude AD to BC and this altitude PS to QR. Now it's given that AD and PS are in the ratio 4/9. So what we have given? We have given that AD by PS. This is the ratio of two altitudes equals to 4/9. Right, students? Now we have to find the ratios of the area of triangle ABC and triangle PQR. Now you have to find the areas. Now we know that if these altitudes are to the similar triangles, these altitudes are in the two similar triangles, then the square of these altitude will be equals to what? The ratio of the triangle. Okay. Okay, in this first theorem we have proved that in the first step, right? Now let's start doing the question. That's a solution, that to find what we have to find. Area what? Triangle ABC upon area of triangle DE and F equals to what? We have to find. So solution is here, that area triangle A, B and C upon area of triangle D, that is PQR, okay, which is given PQR, students. Okay, this is also PQR. So this is equals to what? Altitude of triangle ABC square altitude of triangle what? Say PQR, the other one is PQR square. This implies that area triangle ABC by area triangle PQR is equals to 4 square by 9 square, right, students? So it will be giving you what? 16 by 81. Okay, so simply this is the answer. You can also write it like area triangle ABC ratio area triangle PQR equals to 16 ratio 81. Now this is your what? Required answer. Isn't so simple? So it is very simple to apply theorems in question, but the thing is that you have to know that what are the theorems you have studied. So you have to learn these theorems. Okay, student, this is the one. Now what is next? Let's move. Okay, students, let's move to the next one. If triangle ABC and DEF are similar such that the area of triangle ABC is equals to 16 centimeter square and the area of triangle DEF is 25 centimeter square, students, and BC equals to 2.3 centimeter, find the length of EF. Now understand these questions. Okay. What we have asked, that we have given with the area ABC. I have told you that whatever you are asked, you have to just draw figures first and then you have to write given things and then what you have to prove and then start the procedure, and what you in this case you can write that what you have to find out. Okay. So this is your triangle ABC and then again my favorite DEF. I know it's your favorite also. Okay. So that area of triangle ABC is 16. Now triangle ABC's area is 16. So given area triangle ABC equals to 16 centimeter square, and the area of the DEF, area of triangle DEF is equals to what, my dear students? It is equals to 25 centimeter square, right? And BC equals to, this BC equals to 2.3 centimeter, and it's saying we have to find that the value of length of EF, right students? So we have to find EF equals to what? Now students, EF is this and BC is this. Now my dear students, in this theorem we were saying, it's saying that the ratio of the two areas, similar areas, are equal to the ratio of squares of any two corresponding sides. Now BC and EF are two corresponding sides, students. So by that we can say what? Area triangle ABC, area triangle ABC is what, my students? That is by area triangle DF will be equals to what? Any two corresponding sides. It will also be equals to AB square and by D square, but this is of no use. We are having BC square here, and we have asked about EF square. So we will apply only BC square by EF square here. Now I can just write it like the given, putting the given values, that's ABC is 16 and area triangle DEF is 25. Now BC square 2.3 square equals to EF square. Now what you do, that why leaving 16 and 25 in this form, convert it in square form also, 4 square upon 5 square, right students? 2.3 square upon EF square. So you just cut out these squares because we are having squares on all the sides, so we will just cancel it out, and we will be having this EF equals to 2.3 multiplied by 5, okay, and this 4 here, right students? This 2.3 here, this 5 here, this EF here, and this 4 here, right? Okay, so we can just solve it, and that will give you EF equals to what? 15, 5, 1, 11, 11.5 by 4. Now solve it and you will get the answer. Okay, so this is your answer, my dear students. You can further solve it like this, that 11.5 by 4, 8 times 32, then 3, 0, 7 times 28, 2, 0, 4, that is 2 na, right, 2. Okay, so you can write it here also. We'll be getting 3 and now 28, then 3, okay. So you will be getting this as your answer. So you can solve it and then write the answer, okay. Mark it, I am going to rub. Okay students, so see how simple it is to solve this kind of questions to you. Now students, What is next? Okay, let's see. Theorem. Okay, converse of in a right angle triangle. This is not converse of Pythagoras theorem, it's Pythagoras theorem itself, student. So correct it. To forget this converse, we have to prove the converse. Okay, so Pythagoras theorem, only this. Pythagoras theorem is what? In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. What is a right angle triangle, student? You know from your childhood that a right angle triangle is a triangle ABC in which you are having an angle equals to 90 degree. Now this angle can be this angle can be this also. Okay. This angle can be like this also. Okay. So only one angle can be 90 degree. Okay. So what it's saying that if I am assuming this this right angle triangle, okay, I am assuming that this is my right angle triangle and this is somehow B, this is A and C. Okay, students. Now it's saying that we have to prove that the hypotenuse is this AC, other than this 90 degree sides, we are having AC. We have to prove that this AC square is equals to what? Sum of the squares of other two sides. Sum of the squares of other two sides are AB and BC. So sum will be AB square plus BC square. Right, students? So we have to construct something. We are constructing here a point called D. It's an altitude to AC. Okay. So construction is what? BD perpendicular to AC, students. Okay. Now with the proof. Talking about the proof, if we take this triangle ABC, okay, students. Now triangle ABC and the triangle ABD. Mark the students. I am taking triangle this ABD and this complete triangle ABC. Okay. So ABC and triangle what? ADB. In this, students, I can say that angle A equals to angle A, same angle, or I can say more accurately common angle. Yes, angle A is common in both these triangles. Okay, students, A and A are common. Okay, so let's do one thing. We will be taking these two triangles. These two triangles, it will be very easy to understand it in this way. Okay. So I am taking two triangles simultaneously. In this part, we'll be having triangle ABC common in both. Triangle ABC common in both. But what? And triangle here ABD and here triangle BDC. So if you look in ABD and the complete triangle ABC, this angle is common, right, student? So angle A equals to angle A. This is common angle. Okay students, so I'll write just here, if I look in triangle, this BDC and this triangle ABC, what is common? Angle C is common. So angle C equals to angle C, common. Okay students, now look, this angle is 90 degree, this angle is 90 degree. So angle BDA is 90 degree and angle BDC is 90 degree. So we can write angle BDA and angle BDC equals to what? Angle B is 90 degree. By I have assumed that this right angle is having right angle at angle B. So is equals to angle B. Here also it is equals to angle B. So my dear student, these two angles are similar here, these two angles are similar here. So what? So by, say what? Angle similarity, right? Triangle ABC, triangle ABC is similar to triangle what? This triangle ADB and also similar to what? Triangle CBE CD and B. Okay, ABC is similar to BDC because angle C is equals to angle C and angle D equals to angle B here. Okay, so these are similar to each other. Now, if these are similar to each other, can we just apply the proportion? If I apply from these two, I will be having AB by AD will be equals to BC by DB equals to what? AC by AB. Okay students, now from this and this triangle similarity we will be having again AB, BC and AC, and that will be equals to what? BD, DC and what? BC. Now students, I am picking up the proportions that are having something equal in each other. Now this portion is also equals to AB and this portion is also having something AB. So I will pick this and this. In this we are having this AC. We are having any AC? No. We are having BC common here and here also. So I will be picking these two. Okay students. So I will be naming it 1 and 2. Okay. So this implies by 1 we can have AB square equals to AC multiplied by AD. By 2 I can have what? BC square equals to what? AC multiplied by DC. Okay students, now I will name it third and I will name it fourth student. Now I can do what? I want to prove that AB square plus BC square is equals to AC square. Now I am having AB here and BC square is here. So I can just simply add the equations to get the required result. So my dear students, I am rubbing this part till here. So just note this part. Okay. I am creating a line here so that you will not be confused. Okay, that's what's the starting and what's the ending. Okay, now adding equation. This is what? Third and this is what? Fourth. Adding equation third and fourth, what we'll be having is AB square plus BC square will be equals to what? AC multiplied by AD and plus of AC multiplied by DC. Now I am having common this term AC here and AC here. So I will be simply saying that AB square plus BC square is equals to what? Nothing but common AC, and in bracket I will be having AD plus DC. Students, now tell me what is AD? What is AD? And plus DC? It is nothing but AC. So can I write here AC also in the place of AD plus DC equals to AC. So I will just putting it here and it will be giving me AB square plus BC square equals to AC multiplied by AC. Now I can simply say that AB square plus BC square equals to nothing but AC square. Isn't it, students? So this is what I have to prove here. AC square equals to AB square plus BC square. Hence proved, my dear students. Write it, mark it here, and just again see the process how we are doing this. Okay, we were having this triangle ABC. We created an altitude BD. After that, what we have done? We have take this pink color triangle and this complete ABC triangle, and we have proved that this triangle is similar to what? This triangle ABC. Then we have taken what? We have taken this yellow triangle DBC and the complete triangle ABC, and then we proved that this triangle BDC is similar to triangle ABC. Okay, this is the process we have done till here, and by the Thales theorem, Thales proportionality theorem, we have written the three proportions here like this. This for this pink and complete triangle, and this for yellow and complete triangle. Then we snatch out the useful terms which will be having a particular side 2 times in proportion. So we will be using these proportions from here and these proportions from here, and we will be adding them. After simplification, we will be adding them, and after adding them, we will be having a required results, my students. So note it. I am going to rub this. Okay, students. So as you have seen that there is something converse of Pythagoras theorem also, because it is not converse of Pythagoras theorem, but there is something like converse of Pythagoras theorem. So yes, it is. So in our next in our next lecture, what we will be going to do, we will study somehow the converse of Pythagoras theorem, and we will do some questions on it also, right, students? So till then, take care. Bye.